Hello everyone, good evening. In this particular video, we are going to discuss a few problems pertaining to the three rules that we have got introduced to in the previous session, namely the total derivative rule, chain rule, and the rule which helps us to find out ordinary derivatives using partial derivatives. Right? So to begin with, we'll take up this problem. As you can see in the question, we are given a function z which is x cube plus y cube, where x is given to be u square minus v square and y is given to be u plus v. We are told to find dou z by dou u and dou z by dou v. Right? So this is exactly what is to be done in this particular problem. So the solution part of it would be in this way. So to begin with, we'll try to represent this relation between z and x and y in terms of u and v using the picture that we have learned in the previous session. So as we can see here, z depends on x and y, right? And x depends on u and v. So I'm going to have two arrows from x to u and v, and y also depends on u and v. So accordingly, we'll put two more arrows from y to u and v. So this is exactly what is given, right, as the relation between the given variables. Now, as you can see in this, as discussed in the previous session, z is the dependent variable and u and v are the final independent variables. So obviously we should be able to find out the derivatives of z with respect to u and v, and because z depends on two independent variables, we should be able to find out dou z by dou u and dou z by dou v. So we should be able to find out dou z by dou u and dou z by dou v. Right? Now the question is, what are dou z by dou u and dou z by dou v? So from this relation, as we can see, dou z by dou u, obviously we'll have to use the chain rule, right? So according to the chain rule, dou z by dou u is given by dou z by dou x into dou x by dou u plus dou z by dou y into dou y by dou u. How did we get this? So z depends on u, right? So we are supposed to find dou z by dou u. So as we can see here, z is given in terms of x and y are given in terms of u. Accordingly, z with respect to x has to be differentiated first, and then x with respect to u has to be differentiated, and likewise z with respect to y has to be differentiated, and z has to be y has to be differentiated with respect to u, right? Or in other words, this expression dou z by dou u, finding this is equivalent to finding the roots, all roots possible from z to u, because there are two roots from z to u through x and through y. We have two terms here. So one is from z to x and then x to u, and correspondingly another root from z to y and then y to u. Similarly, if you have to find out dou z by dou v, this would be dou z by dou x into dou x by dou v, because from z we can go to x, and then from x we can come to v. Similarly, the other root would be from z to y and then from y to v. Right? Now, if we know how to write these two rules, the rest becomes very easy. Okay? So in this, the rest would be to substitute what all we know based on the given relation. So as we can see here, write it down here, z is given to be x cube plus y cube. So if z is x cube plus y cube, dou z by dou x is simply 3x square, right? And dou z by dou y is going to be 3y square. Similarly, x is given to be u square minus v square. Accordingly, dou x by dou u is going to be 2u, because v is going to be constant when we are differentiating x with respect to u, and dou x by dou v is going to be minus 2v. Similarly, when we take y is given to be u plus v, and because y is u plus v, dou y by dou u is going to be 1, and dou y by dou v is again going to be 1. Right? Now we'll use all these expressions in the expression for dou z by dou u. So dou z by dou u is dou z by dou x into dou x by dou u. So dou z by dou x is 3x square. So this will be 3x square times dou x by dou u. Dou x by dou u is nothing but 2u. So this will be 2u plus dou z by dou y. Dou z by dou y is 3y square, and then this multiplied with dou y by dou u, and dou y by dou u is 1. So this will be 1. Okay. So this is effectively equal to 6x square u plus 3y square. But of course we should not be stopping here, because finally the variables have to be in terms of u and v. Everything, the right hand side should be in terms of u and v. So we'll substitute for x and y here. So 6 into, as we know, x is u square minus v square. Okay. So this should be square u, because we are substituting this for x square, and then plus 3 into, when I say y square, y is u plus v. So this will be u plus v the whole square. If you want, you can simplify this further, or you can leave it as it is. So this is the expression for dou z by dou u. Right? Now similarly, now we can find dou z by dou v. So dou z by dou v equals dou z by dou x. Dou z by dou x, as we can see here, is 3x square. So this will be 3x square into dou x by dou v is going to be minus 2v plus dou z by dou y. Dou z by dou y is going to be 3y square, and dou y by dou v is 1. So this on simplification will give us minus 6x square v plus 3y square. So once again here we cannot stop here, because everything should be in terms of u and v, because those are the final independent variables. So this will be minus 6 into, what is x here? X is u square minus v square. So this will be u square minus v square the whole square into v plus 3 into y is u plus v. So u plus v the whole square. As always, you can simplify this further, or you can leave this as it is. So these are the expressions for dou z by dou u and dou z by dou v. So that answers the given question. Okay, so this is exactly how you will have to use the chain rule. Okay, now we'll take up another problem, a similar problem here, and we will answer that question also. Yeah, in the second question, as we can see here, we are given that u is 2x and v is 3x square, and x is given to be e to the power 2t, right? And in this question we are told to find du by dt, and specifically we have been told that we will have to use partial differentiation. Why is this specifically given? It is because if you are simply told to find du by dt, what you can do here is that you can simply replace x by e to the power 2t, okay, and then you can easily find out du by dt. In fact, the question is supposed to be containing another term to be found. So I'm modifying the question for you a little. Okay, so the question is, if u is 2x and v is 3x square, okay, find du by dt is what is given. Okay, now to answer this question, once again we'll make use of the diagram that I have drawn earlier. So as you can see here, u is given in terms of x, okay, and x, as you can see here, is given in terms of t. I'll modify this question a little further because otherwise I may not be able to use the required expressions. So the modification that I'm going to do would be this. Okay, bear with me for a little time. So suppose we have the question as like u equals 2x plus 3y this one, right? This one, right? Yeah, if u is 2x minus 3y, where x is equal to t and say y is going to be 3 e power t, okay, then the question is about finding du by dt using partial differentiation. Okay, so as you can see here, now the relation changes a little. I'm going to change that whole thing and then rewrite this. So as you can see from the question, u is given to be a function of x and y because u is 2x minus 3y, and as you can see here, x is a function of t and y is also a function of t. Okay, so u is a function of x and y are functions of t. So as always, if I try to understand the final relation, u depends on t, and because u depends only on t, we will have to find out du by dt. Okay, now what is du by dt? Now what rule are we using? So whenever we are trying to find out ordinary derivatives involving composite functions, we will have to use the total derivative rule. How do we write the total derivative rule? Once again, it's the same logic. Du by dt, writing the expression for du by dt is similar to finding the ways from u to t. So as you can see here, there are two ways. One is from u to x and then x to t, and the other one is from u to y and then y to t. Here, when I go from u to x, I'll have to write dou u by dou x. It is because u depends on both x and y, and because of that we will not be able to find out the ordinary derivative of u with respect to x. Okay, and then from x to t, as you can see, x depends only on t, and because of that we should be writing dx by dt here. So this is one way. Now the other way, similar to the previous way, would be from u to y, wherein we'll have to write dou u by dou y because once again u depends on both x and y, And from y to t there is only one way, or because only y depends only on t, this should be dy by dt. Okay, so this is the expression for du by dt. Now I think in this problem it's very easy to find out all these terms and then substituting them. So I'll simply write down these expressions straight away. So as you can see, u is 2x minus 3y. So accordingly dou u by dou x is going to be 2. And then dx by dt. X is e to the power 2t. So dx by dt would be 2 e to the power 2t. Okay. Plus, now dou u by dou y. What is dou u by dou y? It's going to be minus 3, right? And dy by dt, as you can see from this, will be 3 e to the power t. So effectively, this is 4 e to the power 2t minus 9 e to the power t. Of course, you cannot simplify this any further. So this will be the required expression for du by dt. Is that clear? Fine. Now, if you are able to follow this question, we'll now move on to the next question of consideration. Yeah, the next question, as you can see, is about showing that some expression holds based on a given function. So quickly we'll establish this relation of variables in terms of a figure, and just before that I'll do a small substitution so that things become very easy for me to proceed further. So as you can see here, u is going to be a function of x by y, comma y by z, comma z by x. Because of that, what I'll have to do is I'll have to understand x by y as one variable, y by z as another variable, and z by x as one more variable. So what I'll do is I'll simply take say r to be x by y. Okay, then I'll take s to be y by z and t to be z by x, right? So in such a case, what do we have as the expression, as a given expression? So the given relation can be rewritten as u equals f of, since x by y is x by y is r, y by z is s, and z by x is t, we have u equals f of r comma s comma t, right? Where I can simply use this expression itself, where r is x by y, s is y by z, and t is z by x. Okay, just to make you things understand in a better way, and to make things look much simpler, I'll write this expression far from the previous expression so that things are easily understandable. Okay, so this is what is the relation that we have. Now based on this, we are supposed to show some result. Now before going for that result, we'll try to understand this relation once again using the figure pictorial representation. So as you can see here, because we have u as a leftmost variable, we have u in terms of r, s, and t. So we'll have 3 arrows from u to r, s, and t respectively, one each. And then as you can see here, this part is very important. R equals x by y. So r depends on x and it depends on y, right? Similarly, s equals y by z means s depends on y and s depends on z. Okay, one second, I'll write this little in a better way. So s depends on y and s depends on z, and t depends on z and x. What I'll do is this looks a little clumsy, so I'll just erase this and rewrite this whole thing. 1 second. Yep, I'll rewrite this in such a way that this looks much better. So U depends on R, S and T, and R depends on X and Y. Now S depends on Y and Z, and T depends on Z and X. Right? Now this gives me the relation between the given variables. Now based on this, as you can see here, U effectively depends on X, Y and Z. Right? Now once U depends on X, Y and Z, we should be able to find out 3 derivatives, and particularly 3 partial derivatives, which are of the form dou U by dou X, and then dou U by dou Y, and then dou U by dou Z. Okay, now the question is, what is dou U by dou X going to be equal to? So from this, as you can see, dou U by dou X is equivalent to finding the roots from U to X. So that will be in terms of U to R, R to X, and then U to T, T to X. And very importantly here, you do not have a root from U to X through S, because there is no arrow from S to X. Okay, so I have 2 different roots. Accordingly, I'll have 2 different terms for dou U by dou X. And now the first root is from U to R and then R to X. Because U depends on R, S, T simultaneously, the first term would be dou U by dou R, not du by dr. Okay, so dou U by dou R into, then R depends on all the 3 variables X, Y, Z. So this will be dou R by dou X, not D. Okay, next, that is one root from U to X through R. And now I have another root from U to T and then T to X. Accordingly, the next term would be dou U by dou T, so U to T, and then T to X. Once again, this should be dou T by dou X. These are the only 2 terms that are going to be there in the expression for dou U by dou X. Okay, so this will be dou U by dou X. Likewise, if I have to find out dou U by dou Y, what will it be? Dou U by dou Y. So this will be from U to R, R to Y, and then U to S, S to Y. And once again, I do not have a root from U to T and then T to Y, because there is no arrow from T to Y. Okay, so accordingly, the expression would be dou U by dou R into dou R by dou Y plus dou U by dou S into dou S by dou Y. Right? Similarly, when I go for dou U by dou Z, from U to Z, I do not have a root from U to R and then R to Z. There is no arrow from R to Z, so I do not have a term involving R. So I have one root from U to S and then S to Z, and the other root I have from U to T and then T to Z. So accordingly, this will be dou U by dou S into dou S by dou Z plus dou U by dou T into dou T by dou Z. Right? Now the rest would be about finding these terms and then evaluating them. So for that to be done, I'll just copy this down so that I can go for the differentiation easily. I'll use that expression in this page so that things become much easier to understand. So because we have this relation, we will start with the expression for dou u by dou x. So dou u by dou x, what will this be now? First of all, dou u by dou r. Dou u by dou r is about finding the derivative of u with respect to r, because u is given to be f of r comma s comma t, where f is a general function. We will not be able to find the exact expression for dou u by dou r, so we'll simply retain it as it is. Okay, and then this multiplied with, when I say dou r by dou x, as you can see here, r equals x by y. This is a specific function, so we should be able to find out dou r by dou x. So obviously dou r by dou x will be 1 by y, because when we are differentiating r with respect to x, we will have to keep 1 by y constant, and derivative of x with respect to x is 1. Okay. Plus, similarly now, dou u by dou t. Once again, u is an arbitrary function of r, s and t. So dou u by dou t will remain as it is into dou t by dou x. Now t equals z by x. Now what will be dou t by dou x? Z will be remaining as it is, and the derivative of 1 by x will be minus 1 by x square. So this will be minus z by x square. So accordingly, this will be 1 by y dou u by dou r minus z by x square dou u by dou t. Now this is dou u by dou x. Okay. Now similarly, now we will find out dou u by dou y and dou u by dou z. But just before that, I will try to segregate these things by drawing two different lines so that I will be able to understand things in a better way. Okay, so now coming back to the required expression, I'll go for dou u by dou y. What is dou u by dou y? It is dou u by dou r into dou r by dou y. Once again, dou u by dou r cannot be found as such, so I'll write it as it is here. This will be dou u by dou r. Okay, into, now dou r by dou y. What is r? R is x by y. So accordingly, once again I'll write this once again so that this can be written neatly. Dou u by dou r into, what is dou r by dou y? It is going to be minus minus x by y square. Here x is a constant and derivative of 1 by y is minus 1 by y square. Okay, so the first term will be dou u by dou r into minus x by y square plus dou u by dou s into dou s by dou y. Here is going to be 1 by z. So this implies dou u by dou y is going to be minus z by y square dou u by dou r plus 1 by z dou u by dou s. Right? Now similarly, when we go for dou u by dou z, I will not provide more details pertaining to the substitution of these terms and all. I'll straight away write down this expression. This will turn out to be minus y by z square dou u by dou s. You can check it out later on as to why this happens. And then the next term would be 1 by x dou u by dou t. Okay, so now that I've got dou u by dou x, dou u by dou y, dou u by dou z, now I'll see as to how to establish the required relation. Now what are we supposed to show that? What are we supposed to prove? We are supposed to show that x dou u by dou x plus y dou u by dou y plus z dou u by dou x is going to be equal to 0. So we will start with this expression now. Okay, so we will consider x dou u by dou x plus y dou u by dou y plus z dou u by dou z. Of course, we are supposed to show that it is equal to 0. Okay, so we will not take it equal to 0, but we are going to prove that this is going to be 0. Now, how do we do that? Now, this is equal to x into, what is dou u by dou x? As we have got it here, this will be x into 1 by r. I will shortly write this as, I'll write it in short form as ur. This is allowed, as we know. Ur means u has to be differentiated partially with respect to r. Okay, then minus z by x square. I'm sorry, I think this is supposed to be 1 by y, right? Yeah, I got this wrong. So 1 by y into ur, then minus z by x square into ut. So this will be the expression for x into dou u by dou x. And then we have plus y into dou u by dou y. What is dou u by dou y? Minus z by y square into ur plus 1 by z into us. Okay, and then plus z into dou u by dou z is minus y by z square into us plus 1 by x into ut. Okay, so this is equal to, what do we have here? The first term will now be, when I multiply x inside, this will be x by y ur minus, now the second term has x square in the denominator. When we multiply x, this will be minus z by x alone. So minus z by x ut. Right? Now similarly, the next term will be minus z by y ur. Okay? And then plus y by z us. Right? And then minus y by z us plus z by x ut. And we are supposed to get this as 0, so we should be able to get this as 0. Have you got it as 0? As you can see, y by z us minus y by z us will give us 0. They will get cancelled out, and then we have a z by x minus z by x ut plus z by x ut, which will again get cancelled out. And I think we have missed out one term, I believe. Have we gone wrong with any term? I think these two are supposed to get cancelled out. Are they going to get cancelled out? Yeah, I think I went wrong with this expression. So this is supposed to be minus x by y square, right? So this is minus x by y square. Accordingly, this term should be minus x by y ur. So here these two terms also will get cancelled out, and of course we will be left with nothing on the right hand side, which effectively will give me 0. And this is exactly what was supposed to be proved. So this completes solving this problem. Okay, so as you can see, it all depends on how you understand the relation between the given variables in terms of such a figure. I know it looks a little complicated, but if you try this out and practice this, things are going to become much easier. So once you are able to establish this figure and consequently the relation between the given variables, writing the rule becomes easier. And once you have got the rule properly, finding the derivatives also is going to become much easier. Okay, so this is exactly how we'll have to use the chain rule and the total derivative rule. Now I'm going to wind up with this session wind up this session with another problem that has to be solved. This is a much simpler problem, as you can see from the solution that I'm going to discuss right now. Yeah, what's the question now? We are given that x cube plus y cube is 3xy, and from this we are supposed to show that, or we are supposed to find dy by dx. Now, I think we have seen such a question earlier in our lower classes, probably PU classes, wherein we are given such a relation between two variables x and y. This is exactly what we call as an implicit function. Okay, so implicit function is what we have, and because we have only two variables here, we can assume that one is a dependent variable and one is the dependent variable and the other one is the independent variable, and we can differentiate the dependent variable with respect to the independent variable. So in our PU classes, what we have done here is we directly operate dy by dx on both the sides and then use chain rule and then find out dy by dx. But now we are supposed to do the same using partial differentiation. And for this to be done, we will make use of the last rule that we discussed in the previous session, where we can find out the ordinary derivatives using partial derivatives using this rule. So just to recall, I'm going to tell you how to use this rule. Once we are given the relation between two variables, say x and y, we rewrite the expression as f of x comma y equals c, and then take that function f of x comma y to be u. And the rest is very simple. Once we have got u as f of x comma y, we find out dou u by dou x and then dou u by dou y, and then dy by dx is going to be simply minus dou u by dou x by dou u by dou y. Okay, now we'll do exactly that in this problem because that's exactly what is being asked here. So as we can see here, x and y are related by this expression. So first of all, we will rewrite this in such a way that we get a constant on the right hand side. And I think all of you would agree with me that the best constant is 0. Okay, so I'll simply take 3xy to the left hand side so that the right hand side becomes 0. Okay, and now once I got this, what I do is I'll now take this left hand side part, which is equal to 0, to be u. So what I'll do is I'll take u to be x cube plus y cube minus 3xy, and of course this is also going to be equal to 0, right? Equal to 0. Now once I've got this, then the rest is going to be very easy for me to proceed further, right? So how do we find dy by dx then? Then according to the rule, we have dy by dx to be equal to, what is it? It is minus dou u by dou x. So this is minus dou u by dou x divided by dou u by dou y according to the rule, right? So this is going to be equal to, how do we find this? This is equal to, now what is dou u by dou x? U is x cube plus y cube minus 3xy. So if this is u, dou u by dou x is going to be, yes, this should be 3x square minus, this is 0 when differentiated, and the next term would be 3y, correct? So this is dou u by dou x, and similarly, what is dou u by dou y? Dou u by dou y would be 3y square minus 3x, right? So accordingly, now when we have to write dou u by dou x, we'll simply substitute this expression. So this is 3x square minus 3y, 3x square minus 3y, so that's the numerator, divided by, What is dou u by dou y? This will be 3y square minus 3x. And this straight away gives me what is dy by dx. Of course, I can simplify this a little further. So if you have time in the examination, probably you can try simplifying this. So this is minus of, so if I take 3 common, I can cancel it off and I will be left with minus of, x square minus y divided by y square minus x. Or this, if I take minus inside, this would be y minus x square divided by y square minus x. So this will be the required expression for dy by dx. So as you can see here, dy by dx, finding dy by dx is going to become much easier if you can use partial differentiation. Right? So this is how you can differentiate an implicit function and find dy by dx using partial differentiation. Right? Now these are the 4 problems that I wanted to discuss in this particular session. Now go through all these 4 problems once again and try to solve each of them by yourself. And if you will be able to solve each of these problems, then you will be able to solve any problem, I believe, on total derivative rule or chain rule or implicit differentiation. Right? So saying this, I'm going to end with this session. So study well for the examination. I'm going to post more videos very soon. So go through the videos and try to understand what is being discussed, and do comment on the videos if there is any particular concern that has to be discussed as such. Okay, so with this I'm going to stop this session. So thank you for your patient listening. I'll come back soon. See you.